I want to take a look at our nice angles in terms of their radian measure. Okay. To me, this is sort of the beginning of not having to do converting back and forth. I want to be able to just think in radians. I don't want to always be switching back to degrees. So here we go. I'm going to start with an angle all the way around, right? That's 360 degrees. It's 2 pi radians. So 2 pi radians is 360 degrees. If we cut that in half, so you got an angle that's only halfway around. Well, if you take 360 degrees and cut it in half, that's 180 degrees. If you take 2 pi and cut it in half, you just get pi. So pi radians is the same as 180 degrees. It's that half of a turn, half of a circle. Notice pi, remember, this is 3.14159, whatever, right? So it's a little more than 3 radians. Sometimes we forget that this pi is actually a number, and it's like, why are there always pi's in radians? There's not always pi's in radians. It's just that it turns out our nice angles are easily expressible in terms of pi. I mean, 3.14 is a funny number, but half a turn's an angle we want to be able to talk about. 180 degree angle, pi radians. Okay. Oh, looking back at this one, if you find yourself, up on the mountain doing some snowboarding or whatever, and you're going off jumps and you're doing all these radical moves, rather than doing 360s, you can impress your friends by doing 2 pi's. Right. Anyway, here we go. We took that 2 pi, cut it in half to be pi. So 180 degrees is the same as pi radians. If I take that 180 degree angle, or that pi radian angle, and cut it in half into 2 equal angles, so that this angle and that angle are the same, each one of them is going to be pi divided by 2. Right? This one's also pi divided by 2. Right? 90 degrees and pi over 2 are the same angle. Pi over 2 radians is the same as 90 degrees. I don't really have this memorized. I just have the picture. It's like I take 2 pi, cut it in half to pi, cut it in half again to pi over 2, or I take 360, cut it in half to 180, cut it in half to 90, and I end up with the same angle, just measured differently. So each angle there is pi over 2. I should notice that I can use these now. If this angle is 1 pi over 2, right, from here to there, then if I do that twice, that should be 2 pi over 2's. Well, notice 2 pi divided by 2 is pi. I mean, that's what that angle is there. Or if you think about the angle that goes all the way around, 3/4 of the way around the circle, well, you've turned through, there's an angle of pi over 2 to here, then another angle of pi over 2 to there, and then another angle of pi over 2 to there, for a grand total of, you did 3 pi over 2's. Now I write it like this. It looks like you're taking 3 pi and dividing it by 2, but I think like 3 times pi over 2. They mean the same thing. They're the same value, but when I'm thinking of an angle of pi over 2, and I've got 3 of them, so 3 pi over 2 is 1, 2, 3 pi over 2's. That would be the same as 270 degrees. 270 degrees. So 3 pi over 2 radians is 270 degrees. I don't actually always have to write radians in, right? Because we talked about before, angle measure, radian measure is unitless, really. I don't really need to write the radians in there. So anyway, there's dividing by 2. Actually, let's take that 90 degree angle there, that pi over 2 radian angle, and cut it in half. Want both of those to be the same. Each one of them is going to be a half of pi over 2, so that must be pi over 4. So pi over 4 radians is going to be a half of a right angle, which would be half of 90 degrees, must be 45 degrees. So So if that's pi over 4, and that's pi over 4, and that's pi over 4, and that's pi over 4, notice it takes 1, 2, 3, 4 of those angles to make up pi. You have pi divided into 4 equal pieces. Each one is pi over 4. If I looked at an angle that's like this, that's 3 of those. So there's 1 pi over 4, there's 2 pi over 4, there's 3 pi over 4. Well, that would be the same as 135 degrees, but that's 3 pi over 4. Right? I could talk about an angle of 7 pi over 4, let's say. How big is 7 pi over 4? Well, I'm going to start here and say, okay, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over... Well, that was a bad one. 7 pi over 4. That angle all the way around to there is 7 pi over 4s. I don't have to even think about that in degrees. I don't have to convert it to degrees to know how big it is. I know how big a pi over 4 is, and so I have 7 of them. 1, 2, 3, 4, 5, 6, 7. 7 pi over 4. If you want to convert to degrees, it turns out that that's, what, you're 45 short of 360, so that must be 315 degrees. But I don't even need to know that. I know how big that angle is already because I can understand what a pi over 4 is, so I understand 7 pi over 4. All right. Another nice angles. If you take that pi and cut it into 3 equal pieces, well, each one must be pi divided by 3. Right? If you take 180 and divide it into 3 equal pieces, each one must be 60. So an angle of pi over 3 is the same as an angle of 60 degrees. Right? Pi over 3 radians is the same as 60 degrees. If I have an angle that's 2 of those, so if I have an angle like that where this is pi over 3 to here and then you got pi over 3 more, then that angle is 2 pi over 3. Which is the same as 120 degrees, right? 2 60-degree angles. If you wanted an angle of 7 pi over 3, right? What's 7 pi over 3? Well, I'm going to say there's 1 pi over 3. Oh, that's more like a pi over 4. There's 1 pi over 3, there's 2 pi over 3, there's 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. Notice that 6 times pi over 3, the 6 and the 3 cancel out. That's 2 pi, that's once around. 6 pi over 3, 7 pi over 3, so I have a grand total of this angle that turns all the way around and back to there. There's 7 pi over 3. I don't need to convert that to degrees to figure out that it's 420 degrees. I know that I had to go 7 pi over 3s. 6 pi over 3s gets me all the way around. 7 pi over 3 is one more, right? If I take my pi over 3s and cut them in half, so I've got my pi over 3s here and I'm going to cut each one of them in half. Well, I've just taken pi is that much, I've cut it into 6 equal pieces, so each piece must be pi divided by 6. Notice if that angle is pi divided by 6 right there, then this angle is 2 pi over 6. Well, 2 pi over 6 is the same as pi over 3, right? That was that one up there. 2 pi over 6 is the same as pi over 3. If I go 3 pi over 6s to here, well, 3 pi over 6, the 3 and the 6 reduce to be just pi over 2. That's my right angle. If I take 4 pi over 6s, so that angle there, 4 pi over 6, the 4 and the 6 reduce to 2/3. That's 2 pi over 3. That's this angle here, that 120 degree angle. If I take 5 pi over 6, well, the 5 and the 6 don't reduce, so 5 pi over 6 is that angle out there. That's 30 degrees short of 180 degrees. 5 pi over 6 must be the same as 150 degrees. All right? I didn't multiply by pi and divide by 180 or the other way around, whichever I needed to do. I could just see how big is pi over 6. If I've got 5 pi over 6, I can count 1, 2, 3, 4, 5 pi. In this way, all of our nice angles that we had before, if you think about going around the circle, what were our nice angles? There were the 4 quadrant angles, and then in each quadrant there was a 30, a 45, and a 60, right? That worked their way around that thing. So this was 30 degrees, 45 degrees, 60 degrees. Now I'm looking at, well, the quadrant ones are probably the easiest for me. Those are the pi over 2. So there's 1 pi over 2, 2 pi over 2, which is pi, 3 pi over 2, which is 3 pi over 2, 4 pi over 2 would be the same as 2 pi, or 0. Well, sorry, they're not really the same angle, they're coterminal. 0 would be no turn at all, 2 pi would be all the way around once. If you cut those in half, those are your pi over 4s. So there's 1 pi over 4, 2 pi over 4, 3 pi over 4 is right down the middle here, 4 pi over 4, 5 pi over 4 will be right down the middle of the third quadrant. 6 pi over 4, that's the same as 3 pi over 2. 7 pi over 4 is over here. 8 pi over 4 is over here, same as 2 pi, right? 9 pi over 4, 10 pi over 4, you just keep going around. Your pi over 3s are here. There's the first pi over 3. There's the second pi over 3. There's the third pi over 3. And the fourth pi over 3. And the fifth pi over 3. And the sixth pi over 3 gets you back all the way around again. Then half the pi over 3s are the pi over 6s. So there's pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. It looks like I don't have my angles drawn in quite correctly here. That really this should be closer in like that. That is, this is a 30-degree jump. This is a 15-degree jump, right? The difference between 30 and 45 is 15 degrees. And likewise in each of the quadrants, I could be a little more careful with how I draw those in. That these are kind of closer together than those. But anyway, so then you can see that the gap between here and there, that pi over 3 is the same as the gap between there and there, and the same as the gap between there and there. Right? Anyway, so there's my pi over 6s. 1 pi over 6, 2, 3, 4, 5. 6 pi over 6 is right there. 7 pi over 6 is right here. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. And finally 12 pi over 6, but that's all the way back to 2 pi. So those are the nice angles that we had, the 30s, the 60s, the 45s, the 90s, right? All in terms of fractions of pi. Pi over 2s, pi over 4s, pi over 3s, and pi over 6s, right? Those are our nice angles.